Hi everyone, so today I will be presenting an example of a word problem that involves electric potential. Okay, so for the first example, we have an electric dipole consists of point charges Q1 equal to positive 12 nanocoulombs and Q2 equal to negative 12 nanocoulombs, placed 10 centimeters apart. Compute the electric potentials at points A, B, and C. So you can see here in the figure that we have 2-point charges. This is our Q1, the positive one, and Q2, the negative one. So these are points A, B, and C. So we are going to solve the electric potentials at these points. Okay, so I will write first our given. We have Q1, that is positive 12 nanocoulombs, or this is 12 times 10 raised to negative 9 coulombs. Q2, that is negative 12 nanocoulombs, or negative 12 times 10 raised to negative 9 coulombs. Now, the formula that we are going to use is our formula for the electric potential, that is V equal to 1 over 4 pi epsilon naught, the summation of all the charges divided by the distance of the charges from the point. So for point A, we will write our potential as V sub A equal to 1 over 4 pi epsilon naught, the summation of our Q1 over R1 plus Q2 over R2. So R1 is 6 cm and R2 is 4 cm. Okay, so the distance of Q2 from A, from point A. So we can write this in meters form. That is 0.06 meters and 0.04 meters. So substituting these values in our formula, we now have 1 over 4 pi epsilon naught Q1, that is 12 times 10 raised to negative 9 coulomb over 0.06 meters plus Q2, that is negative 12 times 10 raised to negative 9 coulomb divided by 0.040 meters. 1/4 pi epsilon naught is actually our K constant that is equivalent to 8.998 times 10 raised to 9 Newton meter squared over C squared. Now substituting K, we have 8.998, or you can use 9 times 10 raised to 9. So you can round it off and use 9.0 times 10 raised to 9 times the quantity of 12 times 10 raised to negative 9 coulomb over 0.060 meters plus negative 12 times 10 raised to negative 9 coulomb over 0.040 meters. So calculating this, we will be obtaining the electric potential for point A is equivalent to negative 900 Newton meter per coulomb. Or you can write it as negative 900 volts. So take note that 1 volt is equivalent to 1 Newton meter per coulomb. Now at point B, we will still do the same process. VB is equal to 1 over 4 pi epsilon naught times the summation of Q1 over R1 plus Q2 over R2. So in this case, our R1, or the distance of Q1 from point B, that is 4.0 cm or 0.040 meters. And our R2 is the distance of Q2 from point B, that is, you add this, 4 plus 6 plus 4, which will give us 14.0 centimeter or 0.140 meters. So substituting the values, this is K, or the 8.998 times 10 raised to 9 Newton meter squared over C squared times Q1, that is 12 times 10 raised to negative 9 coulomb over R1, 0.04 meters, plus Q2, that is negative 12 times 10 negative 9 coulomb over 0.140 meters. So calculating this, you will obtain 1,930 Newton meter per coulomb or 1,930 volts. Now what about for point C? Now at point C, we will still use the same formula. That's 1 over 4 pi epsilon naught Q1 over R1 plus Q2 over R2. Now, in this case, our R1, or the distance of point C from charge Q1, that is 13.0 cm. And then R2 naman, we have also 13.0 cm. So R1 is equal to R2, or in meters, converting this in meters, you will have 0.130 meters. So substituting this, okay, I will not write first the constant value. So Q1 is 12 times 10 is the negative 9 coulomb divided by 0.13 meters plus the negative 12 times 10 is the negative 9 coulomb over 0.130 meters. So you can calculate this first in your calculator. You will actually obtain 0. Okay. So 1 over 4 pi epsilon naught times 0 will also give us 0. So the electric potential at point C is actually 0. Why? Because the distance of Q1 and Q2 from point C, they are equal, and at the same time, Q2 and Q1 has the same magnitude for their charge, but of opposite sign. Since they are in opposite sign, magma-minus ito, so yung magiging sagot in adding these two variables will give us 0. So there is no electric potential at point C. So that would be all for our examples. If you have questions, clarifications, and suggestions, please feel free to approach me through my Facebook Messenger. Thank you and God bless.